In this video, we'll write the net ionic equation for AgNO3 plus NiCl2. This is silver nitrate plus nickel 2 chloride. First thing we need to do is balance the molecular equation. So this is our molecular equation, and I can see there are two nitrate ions here and just one here. So I'm going to put a 2 in front of the AgNO3. So the nitrates are balanced. Two silver atoms. Let's put a 2 over here. Those are balanced, but now I have two chlorines. Well, that's good. And then nickel, those are fine as well. That's the balanced molecular equation. Now I can write the states for each substance. Nitrate's very soluble. I write AQ, aqueous, so this will dissolve, dissociate into its ions. Chloride's also very soluble, aqueous, another nitrate, aqueous. And when you see silver, you need to be cautious. Silver compounds are often insoluble. Silver chloride is an insoluble compound, one you should memorize. When you put it in water, it doesn't dissolve. It just falls to the bottom. It's a solid. So in this reaction, when these two compounds react, we'll get a precipitate of silver chloride. Those are the states. Now we can split the strong electrolytes into ions, and that'll give us the complete ionic equation. Silver is always a 1+ ionic charge, and the entire nitrate ion is always 1-. Both good to remember. Two silver ions, 2 Ag+, and I won't write aqueous for each one. I'll do that at the end. Plus 2 nitrate ions. Then for the nickel, I can't tell the charge of the nickel just looking at it because it's a transition metal, but I do know that the chlorine forms 1- ions. So I have 2 of those. This has to be 2+. That's why I called it nickel 2. So I have Ni2+, the nickel 2 ion, and then the chloride ion. And this subscript means I have 2 chloride ions. Those are the reactants. For the products, we have this negative charge on the nitrate. We have 2 negative charges, so that nickel, it's still nickel 2. So we have Ni2+, and then for the nitrate, we have 2 of them, 2 nitrates, 2 NO3-. And for the AgCl, the silver chloride, because it's a solid, it won't split apart. We don't split those apart in net ionic equations. We're just going to write 2 AgCl. And that's the complete ionic equation for AgNO3 plus NiCl2. Now we can cross out spectator ions. These are on both sides of our complete ionic equation. In essence, they haven't changed, so we're really not interested in them. In the reactants, I have 2 nitrate ions. I also have 2 nitrate ions in the product. Cross it out. I have a nickel 2 ion here in the reactants and in the products. Cross it out. But everything else, that's unique. And that makes the net ionic equation for silver nitrate plus nickel chloride, nickel 2 chloride. Let me clean this up, add the states, and we'll have our net ionic equation. So this is the net ionic equation for AgNO3 plus NiCl2. You'll notice that we have coefficients of 2, 2, 2. We can reduce that to 1, 1, 1. We don't write the 1 for a more compact net ionic equation. You'll also notice that we have a positive and a negative charge. They balance out. They give this neutral compound. So charge is conserved, and mass is conserved as well. We have silver atom, chlorine atom, chlorine atom. So the mass is also conserved. This is Dr. B with the balanced net ionic equation for silver nitrate and nickel chloride, nickel 2 chloride. Thanks for watching.